him up. They let me take the first panels in-house. Maybe let me start this time out from the middle with the engineer Faith.
So how we can be able to improve our designs, distribution, the vegetation mix, and also the layout of the infrastructure.
I have 10 years experience in Kenya Power, and before I came into the company, the total connected people countrywide were not as much as they are now, because the government came up with policies and called them instructions to connect as many people as possible, and so that meant the grid had to expand very rapidly, and probably that was not planned for. So using that analogy, I would say we have got into many challenges that even led to losses, but now planning is a solution to such a thing, so that instead of growing the way the initial stages earlier were growing pole, you would want to have planned and futuristic planning that looks at the dynamics of this city and the neighboring cities. How is the growth taking place? What are the economic activities taking place? How does that replicate to even external cities like the others, Eldoret, Nakuru, all the way Kitale, Meru, Machakos, all round. And distribution, generation is not out of the question. It is actually the way to go. So that we have distribution, generation all over the country. They could be microgrids or they could be mini grids, but we have to get ourselves prepared to not only provide the infrastructure, but also to have them communicating with each other so that we are able to harness them as needed and also isolate as needed in case of a fault, but also be able to have all of them available to support the inertia. Because when we have that kind of characteristics that led us to have the recent outages and blackouts, I believe we could have, and we should be preparing actually, I know we are, but not for the participants, we are preparing ourselves to be able to allow, even if there's a major need for a large load to be taken out because of a fault, either caused by a flood or something happening to the transmission network, then we should have ability for, especially because we have now this communication using IoT and the smart meters and the smart grids that enable, regardless of where this generation is, it's able to quickly come into the grid as needed. Then I am promising that the future is looking bright, because outages have taught us painfully that it's expensive. As much as it's expensive to lay the network and prepare for a future, and especially expansion and the future growth, it's not as expensive as being in a blackout. Being in Kenya Power, and all of you have witnessed this, where there's plant maintenance, you cry a lot. Now, how about a 10-hour blackout, a 5-hour blackout? I'm sure nobody would want to imagine that. So we have no option but to plan, and to plan to spend money. To plan to spend money to not only put up the infrastructure, but also communication. Because smart grids is the way out for Kenya right now. We cannot have someone calling Takwel, oh, can you bring in Takwel? No. We cannot have someone calling Naivasha, bring in or carry. No. We would want to have these systems already. We have forecasted the demand that we anticipate for the next 2 days, and the anticipated generation is equally ready and available for it to match that demand. And in case anything happens, we have these spinning reserves. So I'm sure KenGen is working towards that, and Ketraco is working towards availing the transmission lines so that we do not have the emergencies that we experienced in 2023. And as a protection engineer, I am confident that if we move with the direction that we are moving, because we are currently replacing every of our substations to be automated, to be on SCADA, whether it's a small station or a big station, then that way we can have visibility throughout the country, all the way from generation, transmission, and distribution network. So I believe it's the way to go, and when we come to the government and the ministry asking for money, because we normally plan, we have a planning department, we really believe that the government should be able to listen to us, because sometimes they say, why so much money? But that so much money will pay back eventually. Because if you only look at short-term plans, then eventual long-term returns will not be granted. But if you look at long-term planning and investment, I am 100% sure that money will pay back.
Thank you, Ruth. I think you dwelled in several aspects of the design. At this point, it's good to understand that most of the power infrastructure in this country, all of them are operating outside. They are outdoor, and they do interact in all the ways with the climate, with the weather. It is also interacting with the public, people. It also interacts with animals. So what does it mean to design a resilient system? One of the biggest considerations that needs to change our mind is that we need to design for the worst case scenario. What we have been doing is, I want to borrow from what Faith has done, is to optimize. What we have been doing in the past is that you need power to move from Nairobi to Kimuka. Do you have a way lift trails that you can use? Yes. Can we design a line through the way lift trails at the optimal cost? That, given the kind of climate change, might not work for us, because we need to ask, how can this infrastructure respond to different weather conditions? And I want to talk on the side of Ketraco. When you check, any weather will affect our lines. Too much heat, too much dry weather will cause higher losses on the line. It will also cause the conductors that evacuate power to loosen, and the chances of swinging and clashing becomes higher. What happens when there is serious rains? There is the inherent risks of flooding, and flooding can move everything that is on the ground. That means that the stations are affected. It means that the tower foundations are affected. And I would like to talk on the real events that have happened over the past. In Longonot, there is a line that evacuates power from Lake Turkana wind power. It's one of the longest lines with a dual circuit with a carrying capacity of up to 1,000 megawatts. The design is almost uniform all the way from Lake Turkana to Susu. But what happens? The weather patterns along the lines are not the same. So what happened in Longonot? The Longonot towers, because of being able to get a better trace without population, we went along the Longonot towers, along the towers in Longonot. What happened with the high winds that was experienced during that time? 5 towers gave in. So you can say that the design was done well. It has served almost out of several towers, only 5 of them went. But what was the impact of that? It was an impact of a national blackout. It lasted several hours. So what do we need to do in the designs? The designs we need to do has to be borrowed from the planning sector. You need to plan using the worst case scenario, and for you to get worst case scenario, you need to be having tools that can predict. Tools can simulate the worst case scenario. We are happy that I have colleagues who are in Moi University who are currently doing some studies, and they are looking at all aspects. They are looking what is the impact of renewable energy that are variabilities that are affected by weather. What is the effect of it on the grid? And they are able to get tools to simulate, and that is where academia and the industry are meeting now. And if one day we converge and sit in a table and say, look, the way you've been doing this is not the best, but I'm giving you a better solution. That is what has not been happening in the past, and I'm happy. I'm happy because in the energy sector, if you see from the Minister of Energy, they are the first one to say, look, we have been told there is a bad weather. KPLC, what are your mitigation measures? What are your risky areas? And what are you doing with it? First, asking that question will take us a long way in adapting to this changing climate. So I'm happy because most of the new designs we are doing now, we are using tools that can simulate the worst case scenario. And one of the things is to avoid areas that are vulnerable, that is one. But when you're not able to avoid, what do? You redesign. And there is something in design called over-design. You can have something that works for that thing perfectly. But at some point you need to spend some little more money and over-design. It will be costly, and that is why the element of cost comes in. And also, at that point now, who are the people to make that decision? Those are the policy makers that needs to understand. And for them to understand, I would like to appreciate the players in the energy sector, the engineers in this country, for coming forward and giving solution. And also, through such events like today, we are able to dispel this information, because ignorance sometimes cannot solve issues. And we need to reduce the level of ignorance on everyone, from the highest level to the players on the industry. So, engineer, that are some of the issues that we need to input on design, looking at the worst case scenario and designing for a resilient system that can adapt to the weather. Maybe to wrap it up, currently in Ketraco, we have 3 pending cases that are direct impact of weather. We have the Logoyane that I've said, we have the Sabaki Bridge, and we have some lines beyond between Susua and Logonot that are still on temporary towers. We are looking for ways now. We are not going to replace just the way it was. We are now designing. We are spending a lot of time to get a design and prove that that design, in the worst case scenario, can withstand the weather. Thank you.
If I bring Engineer for his comments on this, I'm sure he will tell us the beauty of distributed generation, mini grids, and off-grid systems. I just want to follow up with something that maybe Engineer Moi or Engineer Faith can help us state. We plan to mitigate or to avert any challenges, but I'm sure Kenyans most of the time will notice something when it's absent, and that's the case of blackout. I just wanted us to look at a blackout scenario. First, what actually causes a blackout? Probably if it's a fault on the system, it could be a fault on the transmission or distribution system, it could be a fault in the generation system, and then what I would like also our audience to understand in this perspective is, if a fault has happened in one place, how does it happen that then it wipes out our grid? To see how the system gets into that situation, so that our audience can appreciate. And secondly, how do we build back the grid from a blackout situation, and how challenging that can be. And probably the last question on that of the 3 is that is it also possible for us to improve our system in such a way that maybe there's a fail-safe situation for various regions, so that if something adverse happens on the whole grid, then the system can fail safe, maybe to a certain region remaining online, so that it makes it easy to build back from that, as opposed to the black start situations that we have. So I don't know who would like to take that before I come to Engineer Meu, for his comments on this design and especially distributed systems.
It's true that we all have experienced blackouts in the past, and we did not like it. The users and the ones handling the system, it's not one of the best moments to be found occurring. But blackouts are avoidable, and they're avoidable because it's not happening in other countries. So how are they managing it? We need all the players. Now that we have Kengen, Ketraco, Kenya Power, and REREC, but especially now Kengen, Ketraco, and Kenya Power, to enable when power is generated, power is not stored, so power needs to be consumed as it is generated. So that means it needs to be transmitted to where it is supposed to be consumed. So the causes of blackouts could be a fault that was so big, took out a big chunk of the load. The transmission, the generation line, the generation cannot handle that, because you take a load, you need to take out generation. You cannot stop power. And you could have your generation able to carry the remaining, like to take up the load, but you have enough transmission lines to transmit it to where it is supposed. Maybe we have a fault in West Kenya, and the generation that is available is elsewhere. The lines to be able to deliver that power comfortably without having, because you've lost maybe a generation in that same site, is not there. So the options that we have, and we are working towards that, is to have a ring connection of our grid, so that we do not have radio lines, because currently we have several radio, transmission, and distribution lines. So we are working towards having ring networks, so that we have the whole, like if there's a problem here, power can still work backwards to another, to the same place, to another route. We also are working towards having self-healing systems. Just like I said, we are making our grid smart, so that when there's a fault, you don't have to make a call, go check what's the problem, go bring it out, go close that section, go bring it back. So we have self-healing systems in place, and where they are not, they are being put. And we are also enabling we're enabling all generations to be visible, and all transmission lines to be managed from SCADA as well as the distribution lines. But now remember, inertia is also something that we are working on as a country. If we lose something big, how can we hold it, even if it's for a few minutes? So it's a discussion that should cut across Kengen, Ketraco, and Kenya Power. But the good thing is that all of us are willing, and even the government is willing to support us. Currently, we are doing a FMVA at Lesos, and we're also doing another one at Ketraco, and we are doing several other lines. I think one was commissioned this week, and the interconnectivity is what is a solution to avert a future blackout. Actually, faults are common. As a protection engineer, I don't have a problem with the relays operating, because the work of the relay is to operate, to avert a fault from damaging your equipment and life. So when a fault is in the system, the relays should take out that line. But if we have interconnectedness, that section will be removed peacefully and quietly, and the rest of the system shall continue working without even you noticing a problem has happened. So that we are yet to get to that place, but we are putting all efforts there, and it needs money. So we need to have a business case day after day, so that we're able to convince the government to support our projects, whether it's from Ketraco side or Kenya Power side. But we have the papers written, we have the project proposals done, we have some projects started and others are not finished, but they should be finished with time. But all these things Kenyans may not be aware, but we are working. We are not just saying, well, let it happen. We're already planning, and we are implementing what is in our power to do. But we believe, given the next few years, we should be out of blackout zones, because we have engineers who have studied, like engineer here in his doctorate, he's working towards making the grid smart, and we are able to adopt all these studies and be able to implement them. So please hope for the best, right? Yeah, hope for the best.
I know time is not on our side, but I wanted to reinforce what she says, and I want to start by what the people said last time. During the last extreme weather,